Hi, Integrated Math 1. Welcome to lesson 5.2.4a. We're doing day one. So we've talked about translations as functions. We've talked about reflections as functions. Now we're going to talk about rotations as functions. And we know rotation is a turn. I mentioned before that it was measured in angles and degrees and all that. So to kind of kick it off, to kind of get us started, I have a very brief format for you. I just want you to tell me the degree measure of each of these angles, angle ARC, angle ARB, and angle CRB. Go ahead, hit pause, write down your answers. It should be pretty quick, and then hit play when you're ready to check your work. Now, of course, measure of angle ARC. Well, ARC is a straight line, so that's 180 degrees. Yay. The measure of angle ARB, well, I can see that BR is perpendicular to CA. So that means the angle ARB is a right angle that is 90 degrees, as well as angle CRB. It is also a right angle of 90 degrees. So it shouldn't have been too shocking there. So I just kind of want to get our head in the game with angles and degrees. It wasn't meant to be hard, just kind of get us thinking in this direction, because our learning goals for today and next time, we are going to represent rotations in the plane. We're going to describe the rotation transformations as functions, right? We knew this was coming, that take points as inputs and output rotated points, right? We're going to specify a sequence of translations, so reflections, translations, rotations, that will carry a figure onto a congruent figure. Like it might be a combination of things now. So our key terms for today and the next lesson, we're going to be talking briefly about concentric circles and, of course, rotation as well. So you've studied circles and rotations before, right? Circles are not new. You've seen them and used them before. You've studied rotations before, this idea of turning your figure around a point. So we can actually use circles to help us define and describe rotations on the plane. So if you flip over to page 94, I should warn you today you are going to want a compass, and more than a straight edge, you're actually going to want a protractor today. I'm just giving you a heads up. You'll be grateful you have one. So you've constructed circles and identified parts of circles in previous lessons. You know what a circle is. And in fact, you know you can just take your compass and spin it all the way around and make yourself a nice little circle. Circles are really important for understanding rotations. So here on page 94, we have some concentric circles. Concentric circles are circles with a common center point. You can see I have 1, 2, 3 circles here, and they all have a center of E. So they are concentric circles. So here's why we have concentric circles and why we're talking about this with our rotations. I'm going to draw a point on each circle. Let me grab a pen here, such that I can connect them to make a triangle, which we'll call ABC. So it'll be like a point and a point. Oh dear. And another point. Yeah, I got there. And of course, I can call this A, B, and C. So I put a point on each circle. And if I connect them, you should ideally be using your straight edge to connect them on your paper. Of course, I'm doing it on my screen, so they're a little wobbly. But I can make a lovely little triangle here. When I do a rotation, I'm going to grab another color here. When I do a rotation, all I'm doing is moving these points around their respective circles. That's all we're doing. We measure it in degrees like we do angles, and we call it a rotation angle. But all I'm doing when I do a rotation is B is getting moved around the circle, A is getting moved around the circle, C is getting moved around the circle. They're each getting moved around this circle a certain number of degrees. And that's what a rotation is doing, okay? So kind of helps my brain to think of it as like, okay, it's a circle and it's going around, and these points are all moving the same number of degrees around the circle. So if you go over to page 95, we're going to play with this a little bit. A rotation is a function that maps its input, some point P, to another location. So again, it's just going to be a function Similar to our reflection, we are going to use an R for rotation, but this one's going to look a tiny bit different. So I'm going to do R for rotation, but watch what happens now. Actually, I'm going to erase. I'm going to put this somewhere where I have a little more space. Put it over here. So R for rotation. And again, I'm going to have some input, some point P. And so I know that goes in the parentheses, right? P's in the parentheses. Oh, I already know I'm going to run out of space. No, I got it. So my parentheses is my input. And I know it'll spit out some point P prime, right? We know this is going to happen. So my, you know how it goes. That's my input. Oh dear. That's my output, right? We know this. Not surprised by any of this. Sorry, I ran out of space. But remember how in the past with translations, we put the distance down here, right? With reflections, we put the line of reflection. That's what went down here. Because this is a rotation, it actually gets two things put down there. You have to put down the center of rotation. In this case, we'll call it E because that's what we had on those concentric circles, comma, my angle of rotation, which we'll just call T. So notice how there's a comma in between those. We actually have two things when we're dealing with rotations. So we have a center of rotation, and we also have, oh dear, we also have our angle of rotation. Oh my gosh, come on, I can get this to work, I promise. We also have an angle of rotation. So this one's a little bit different. It is an R for rotation, just like we had R for reflection. But this one's a little different than our reflections because I have two things. I have a center, comma, and an angle. Please, please, please remember, counterclockwise is a positive degree angle. Clockwise is a negative degree angle. Please remember that. I know I really tried to emphasize that with you guys the other day, but I'm just bringing it back. So because the rotation is defined about a point, in this case we're saying E, the movement of a specific point traces the arc that's part of the circumference of that circle with a center of E. It's literally an arc. It's chasing it around the circle, right? And the arc can be labeled by the starting point P with an end point of P prime. So we say that's P prime, and instead of a line segment on top, we put a little baby arc on top. It's so cute. It's a little baby arc. The degree measure of this arc is, of course, equivalent to the degree rotation, in this case T, that creates that central angle. So that's our whole idea. We've got our center, we've got an angle, and our point is just following the arc on that circle around that point. So it is possible to apply the rotation function to a figure using a protractor and possibly a ruler. I'm going to be using a compass to help make this a little easier for me. So here's how this works. If you're on page 96, they have these step-by-step instructions. Now, I know they can be hard to follow, so I'm going to show you how this works. This is why I have a camera, people. Actually, more than one camera. This is why I have this camera. There it is. All right. So this is what you have on the page. And again, they've explained all the rotations here. So the idea is you're going to draw. So I want to rotate around a positive 40 degrees. And because I'm rotating an entire segment, I actually have to do it twice. I have to do it for J, and then I have to rotate N. I'm going to rotate each point. So to do this, we draw a line segment from the center of rotation to one of my endpoints. And then we just use our protractor to measure out that 40 degrees. Since it's positive, we're going counterclockwise. Please remember that. And then, of course, I need to measure, use a ruler or a compass to measure how long that side should be. It should be the same as this length. This length and this length should be the same. So you can full on measure that and just be like here to here, here to here, and make a little mark. And there's your new J prime. And then you have to repeat those 3 steps for point N as well. Once you've got your 2 points, you will, of course, connect them up. Now, this can be confusing, so I'm going to show you how this works. You ready? I may zoom in a little bit too. There we go. We see how well this works. So I'm going to use a straight edge and my pencil, and I'm just going to start by connecting my center to one of my endpoints. So I'm just going to use my straight edge and be like A to J. Yay. Now I want a 40-degree angle, and since it's positive, I need it moving counterclockwise. So I'm actually going to flip my little guy upside down here. And I can see that 40 degrees, and I don't know if you can tell, there it is. 40 degrees is out here, so I'll make a little mark. And then I can use my straight edge. Now here's the thing. I don't actually want it that long, do I? Right? I mean, that's way, way too long. That's way, way, way too long for me. So I'm going to use my compass, and I'm going to say, hey, you're not supposed to be that long. I'm going to put the stabby guy on A. I'm going to adjust my pencil so that it touches J. And then I'm just going to come over and swing around and make a little mark. And I'm like, hey, that's where my new point should be. And I can erase all the rest of this just because it's in the way. And I'd be like, hey, look, there's J prime. And now I'm going to do all this again for N. So I'm going to connect A to N. I'm going to connect my center of rotation to my point. Again, I'm moving 40 degrees around. So I'm going to put middle of my protractor on A. I'm going to line it up with N. 40 degrees is over here. I don't actually want it that long though, right? That's too long. That's way too long. I'm actually gonna, I don't want it to be too dashed, otherwise I'm gonna miss things. Right? Okay. So I'm gonna use my compass and say, okay, this is way too long. So I'm gonna measure the distance from A to N. Stabby guy on A. Adjust my pencil till it touches N. And then I can come around and I can make a mark. And I'm like, that's how long you're supposed to be. And there is N prime. You can erase this as excess if you like, or you can keep it. It doesn't really matter. And now that I've moved both of these points, I can take my straight edge and I'm going to connect them up to make J prime, N prime. So here is my new segment rotated around point A forward a positive 40 degrees. And there you go. Now that you've got the idea, I want you to try a few of these. Over on page 97, question number 3, we've got a couple of these. We got A, we got B. I would like you to try both of these. Go ahead, hit pause, work these out, do your rotations, and then hit play when you're ready to check your work. All right, how you doing? How you doing? You got this? Let's see how things are going. I'm gonna zoom back out. This got too close all of a sudden. It's too close. Back up. There, is that a little better? So I'm gonna go ahead and I'm gonna rotate this. First thing we do is we go from E to V. And I'm just gonna use a dashed line. I think that makes it a little easier sometimes. Be all like dashy, 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 dashy. You guys hear how windy it is out there? I don't know. I can hear it. I don't know if you can hear it. We are going a positive 75 degrees. If it's positive, that means I need to go counterclockwise, lefty-loosey. So I'm going to put the center of my protractor on E. I'm going to line up that line with V. Ooh, 75 degrees. That's all there. There's 60, 65, 70. There's 75. Between 70 and 80, right? So there's 75 degrees. And I'm going to go ahead and I'm going to connect those guys. And again, it's way too long. So I'm going to use my compass. Stabby guy on E, pencil side on V. And then I'll just kind of come around. So stabby on A and B. There we go. And I'll just come around and I'm just going to make a little mark here. I'm like, okay, there's my new and improved V prime. Let's do it again for H. I'm going to use the straight side of my compass and I'm just going to connect E to H. Again, I like to make it a dashed line so it's not quite so hard, so many lines to see. We are rotating a positive 75 degrees, so I'm coming down and around. I'm going to put my whole of my protractor over E and line up that side right there with H. 75 degrees at 70, so that must be 75 right here. And again, make my line from my center now out to my 75-degree mark. It's way too long. We know it's way too long, so I'm going to use my compass, stabby guy on E, pencil side on H, and then I'm just going to come around and make a mark. And there's the new one. That should be H prime. And now I'm going to use my straight edge and restore my segment to its former glory. Ooh, look at that. That's a nice rotation. Yes. For the purposes of B, I'm actually going to erase a little bit of what I got back here on A. I may need some space here. So if I come over to E, this one's a little different. My center is now Q. I'm going to rotate negative 30 degrees. So that means if this is Q, things are going clockwise this time. Okay. And I'm going to rotate MN around Q a negative 30 degrees. So I'm going clockwise. All right. So I'm going to rotate M first. I'm going to make a line from Q to M. Pew, 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 pew. And then I'm going to use my compass. The center goes over Q. Now this time I'm moving this way. It means it's still upside down. So I'm going to put my center of my compass over Q. I'm going to line up the side with M. We're going a negative 30 degrees. Oh gosh. So here's now 30s on the outside this time. Are you catching that? Watch out for that. So 30 degrees, that's out here. Again, from Q to that spot, I'm going to just make a nice little line. I know it's too long. It's way too long. I know this. So I'm going to go ahead, grab my compass, stabby side on Q, put the pencil on M. There it is. And then I can just come around. Oh dear, maybe I can come around. Hang on, I gotta turn the page. It's easier. So Q, and I'm gonna make a little mark. And there's my new point. It's now M prime. Very nice. Let's do this again for N. We need to rotate N around. So I'm gonna draw a nice dashed line from Q to N. Okay, I need to rotate a negative 30 degrees. So I'm going to put the center over Q and line up the side of my protractor here with N. 30 degrees is over here. Again, it's kind of on the outside this time, and that's okay. There's a 30 degrees. I'm going to connect that to Q. I know it's way too long, so I'm going to put my stabby side on Q. I will adjust my pencil until it touches N. And then I'll just come over and I'll just make a little mark. So it looks like it should hit right about there. And there's my new N prime. I started off with a segment. I should end up with a segment. So I'm going to connect these two in order to make a nice little line segment. There you go. You just rotated segment MN a negative 30 degrees around point Q. Very nice. So with that in mind, come on over. So yeah, there we go. So here's our first one. We rotated it a positive 75 degrees. This one we rotated a negative 30 degrees. As always, I hope you found this helpful. I hope you found this useful. If you've got questions or concerns, come talk to me. And I'll see you guys soon. Bye.